So we've been learning about real numbers, rational numbers. They're all numbers that exist that can be thought of, that can be visualized. But today we're going to talk about something that's a little more abstract. It's called imaginary numbers. And I is what it stands for. So I is defined as square root of -1. Now let's talk about why it's imaginary. Square root of 4, for example, is 2. Because a square root of something is essentially the square of the radical. So 2 squared is 4. So square root of 4 is 2. Now, so something squared has to be -1. Why does that not work? Because if it's something squared, it's something times something. And it's either positive times positive, which will give you a positive, or negative times negative, which will also give you a positive. So no matter what you use, what number you use, you'll never get the square root of -1. So mathematicians came up with this symbol I that stands for square root of -1. So now we know that I equals square root of -1. And what do we always do with square root? We square it. So if we have root 4 and we square it, it'll just go to 4. Or, yeah. So what we're going to do with I is put it to the power of n. So let's go I squared. And that's going to equal square root of -1. Square root give us -1. And now we do it as instead. We do square root of -1. To give you, we know this here is -1. That'll give us -1 times -1. And now we know this is I. So we consider I. I to the 4th. Now this is -1. -1. So that's just very simple math. It's 1. I to the 5th. Now these will give us 1. And this will give us I. So we go back to I. So we kind of see how this sort of has a rule to it, but how do we use it so it's easier? So if we have I to the n, how do we know what's going to be? So we see when there's 2, it goes -1. When there's 3, it goes -I. 4 goes 1. 5 goes I. So whenever there's an even number, we're going to get something out of it. So how do we find I to the n? First, you divide n by 4. So for every 4, so you group it into 4s, because we know I to the 4 gives us 1. So you're going to have a number, which doesn't matter, because whatever it is, it's going to result to 1 up here. So, and then the essential thing is the remainder. So you find the remainder, and you go I to the remainder. And we know that the remainder is going to be less than 4, because we're dividing by 4. So since the remainder is less than 4, all we need to know is these identities. Or we can just think about them as we're doing it. So that way we know I to the r, which is going to be the same as I to the n, because this is only going to become 1. So it's going to be I to the r times 1. So that's an example. Yeah. Okay. I to the, let's go easy, 10. So like we said here, you go n over 10, oh, 10 over 4, 10 over 4, give you 2, and 2. So you go I to 2, which will give you, here we have 2, make it 1. So the answer to this, I to 10, is negative 1. Another one, I to the, let's go bigger, 276. Whatever. So we go 276 over 4, give you 69 with the remainder of 0. So we know that it groups into a group of 4s. So that would be going essentially I to the 0, which is 1. And 1 times 1 is 1, so I to the 276 1. Because we're grouping 276 i's into groups of 4s. And we know there's going to be 69 groups of these, which are 1s. That's going to give us 1.
So, using I in everyday math is somewhat difficult in the general means, but if you use it the right way, you could incorporate it with real numbers. For example, if you have I, and then you want to incorporate some more numbers, you have like 3I, or 6I, or 17 halves I. However, you can't really do too much with this. So, something we call complex numbers. What they are are numbers that involve I and real numbers. They use the formula a plus b to the I. A being a real number, b is being the coefficient of the I. Some examples of this are 3 plus 4i. 3 is the real number, and 4 is the coefficient of the I. A lot of these complex numbers can be used in multiplying and dividing each other, adding, subtracting, utilizing them in different ways, like adding, subtracting, multiplying, and dividing. So, for graphing real numbers on a number line, it's pretty easy. It's just, so here's your number line, here's your 0, then this goes to infinity and negative infinity in these directions. Let's say if you're going to graph 3, you'd go 1, 2, 3 slots over, and then you write, then there's a 3. That's where there would be how to plot 3 on a number line. But how would you graph something like I on this line? It can't work, because this is the real number line. That means only real numbers can be on this. As we know, I is not a real number. It's imaginary. So, there's a whole new axis for I. It's called the imaginary axis. So, this would be at 0 for the imaginary axis. Let's say you're going to try to plot 2i. You'd have to go up 2, 1, 2. This would be 2i. Say you're trying to graph negative 3i. You'd go down 1i, 2i, 3i. And that's how you would do that's how you would plot the imaginary axis. So let's say you had something as 2i plus 3, which is a complex number. You'll need both of these graphs to graph. So what you should do is put the axes together, and then this is still your imaginary, this is still your real number line. And then put in, okay, go up 2i on the imaginary axis, 1, 2, and go over 3 on your real number line, 1, 2, 3. Where these two meet or is at right here at 2i up and 3 across. Graphing something like 6 minus 3i. You'd go 6 across the real number line. 1, 2, 3, 4, 5, 6. And then down 3i. 1, 2, 3. So this would be where 6 minus 3i would be graphed on this plane. Also, when you're finding absolute values of real numbers, let's say 8. The absolute value of 8 is the distance from 8 to 0, which is 8. If you go back to this example of 3, the absolute value of 3 is 3, because it's 1, 2, 3 spots away from 0. Get an example of absolute value of -6. Here would be 6, -6 right here, and it is 1, 2, 3, 4, 5, 6 spots away from 0. So that would be 6 as the absolute value. However, there is no absolute easy way to calculate an absolute value of complex numbers. 3 plus 2i. The absolute value of this is kind of hard because trying to find the distance from 0. Say here's the example, 2i plus 3. Absolute value of that is 0. You have to find the distance from the point back to 0. So you're trying to find this. What we should use is use the distance formula, which is distance equals square root of, say this is x squared plus y squared. This being x and this being y. The distance would be the root. Let's say in this example, x right here would be the real number line. So that would be the 3. So you'd have 3 squared plus, and you have this would, y would be the imaginary number line. So we have 2i squared equals d. However, we already know when using I to the n, we know that just filling in the rest here, 9 plus 2 squared is 4, and then I squared, as we know from before, is -1. So we know d equals root 9 minus 4, giving us d equals root 5. And that would be the absolute value of 3 plus 2i. So you would know that the absolute value of 3 plus 2i is root 5, just using the distance formula. That's it.
Now we know what imaginary number is, and complex number, and all that. How do we use them? So let's start simple. Let's start with addition and subtraction. So if you have I plus I, what do you have? Well, if you have x plus x, what would you have? You have 2x. So I plus I is essentially the same as 2i. So that's basically how you treat I. You treat it as a variable. So let's talk about complex number. If you have 3i plus 2 plus y plus 3. It's very simple because you would just group the ones with I together and the constants that go together. So basically treat I as x. So you get 3 plus 4, 7i, plus 2 plus 3, 5. And keep in mind, if you're doing subtraction, minus y 3. It's just like any whole number problem. The negative has to carry in here. So in that case, you'll get negative I minus 1.
So, same thing with dividing it, but it's a little bit more tricky here when using complex numbers. So let's say we have the same two complex numbers, 2x minus 3, or 2I minus 3, and then divide it by the other one, 6I plus 2. So same thing by using it by x, 2x minus 3 over 6x plus 2. There's not much you can do to simplify this. However, what we can do is multiply by the conjugate. Multiply by 1, but having in the numerator and the denominator the conjugate. Conjugate of 6i plus 2 is 6i minus 2. Multiply the same by the top, you would get this. Then, same thing as when we were multiplying, multiply this, FOIL it out. 6i times 2i is 12i squared. 2i minus 2 equals 4i. 6i times negative 3 equals minus 18i. And then negative 2 times negative 3 is plus 6. In the denominator, you just multiply 6i times 6i, which is 36i squared. 6i minus 2, which would be 12 minus 12i. 6i times positive 2, which is plus 12i. And then 2 times negative 2 is negative 4. What's good about multiplying by the conjugate is that you're left with this. This 12i, negative 12i plus 12i would simplify to be 0. And this 36i squared, since I squared is negative 1, 36 negative 1, that would be negative 36 minus 4 equals negative 40 as the denominator. Up top, do the same thing. I squared is negative 1 times 12 is negative 12. And then, combining all the terms, that would be minus 22i plus 6. Simplifying that just a touch would be negative 6 minus 22i over negative 40. Then what we should do is divide by negative 2, which would be positive 3 plus 11i over 20, which would be what we would get for division. What we want to do in the dividing is to get rid of the I in the denominator. We're not allowed to have I in the denominator, so we multiply by the conjugate, FOIL it out, multiply, and then simplification will give you an answer that is not in the denominator. With the I, that's not in the denominator.
So now that we've learned about imaginary numbers and some of the usage ways to calculate imaginary numbers, let's do some examples. Let's do some problems. So let's start easy with I to the 17th power. So as we know, I squared equals negative 1. So let's try and group 17 into 2's. So basically I squared times I squared times I squared. So you do 17 over 2 equals 8 and 1. So you know it's going to be I times I, 8 power, and then you have 1 I left behind. Now we know this is going to be negative 1. Negative 1 to the 8 times I will be, well, negative 1 to the 8 will be 1, so it will be positive 1, so the answer is I. So I to the 17th power equals I. Alright, so now let's move on to the harder problem. I to the 361 power. So I'm going to take a different approach because we have a bigger number now. So let's go with I to the 4th as a group. We know that I to the 4th equals positive 1. So if I have 361 i's and I group them into 4, every group will equal 1. So 361 divided by 4 will give me 90 and the remainder of 1. So I'll have I times I times I times I. And that's a group. I'll have 90 of those groups. And I have 1 I left. So we know this equals positive 1. So this whole thing will equal 1. 1 to the 90th power. So times I, which will give me the answer of I. So let's move on to plotting a complex number on the number line. So on this problem, we're asked to plot 3 plus 2i and negative I plus 4. Let's do 3 plus 2i. We have a real number, 3, and we have an imaginary 2i. So on the real number line, we'll go positive 3, and on the imaginary number line, we'll go positive 2. We'll find the point, and apply. So that is 3 plus 2i. And for negative I plus 4, we have negative I, so we go down 1 on our I axis, and then we go to the right 4 on our real number. So that will give us negative I plus 4. So now we know how to plot it. Let's find distance. Let's find absolute value. So as we talked about it before, absolute value on the real number line is the distance from the point to the origin. So it's the same thing for a complex number. So we're asked to find the absolute value of negative 2i minus 6. So let's plot it first. So we go negative 2 on the I-axis, and we go minus 6. So we find the point, negative 2i minus 6. Now from this point, we have to draw a line to the origin. Not very good. Not very straight. Okay. So we have to find the distance of this line. Now how do we do that? We do it with, well, Pythagorean theorem. Find the right triangle. You find the two sides. So you know it's 30. So this side will be 2. Well, 2i. So 2i is our di, so to speak. So squared plus 6 squared and square root. So this is similar to what we had before, where we have 2i squared. 2 squared is 4. I squared, as we know, is negative 1. Plus 6 squared is 36. So this will give us 36 minus 4 square root of 32.
So now we should higher, a little bit more difficult equation of 3i plus 2 minus the quantity of 4i squared plus 2i minus 4 do the same concepts. So if we take 4i squared, which is x squared, for example, we'll keep that over here. So we'll have negative 4i squared. Group up the i's. So it's 3i minus 2i, will just give us a positive I. And then positive 2 minus 4 minus negative 4 would be 2 minus negative 4, 2 plus 4, 6. So that would be a positive 6. Then, since we know that I squared equals negative 1, we could put that in there. Negative 4 times negative 1 plus I plus 6 would be the answer. Minus 1 times minus 4, 4 plus I plus 6, I plus 10 would be the answer. What we could do, however, is that realize at the beginning, oh, I squared, that equals negative 1. So what we'll want to do is we can just put it in there. So we have the equation 3i plus 2 minus 4 times negative 1 plus 2i minus 4. Now if we just simplify that a little bit, or even do any work, would be 2i minus 8, which is it seems a lot nicer than this equation up here. Doing the same thing would give you the same result of I plus 10 as being the answer.
Okay, so we did addition and subtraction. Let's go into multiplication. So you have 3i plus 4 times 6i minus 2. What you want to do is basically treat I as x and just 4. So 3 times 4. 18i squared minus 6i plus 24 minus 8. And now we know I squared is going to be negative 1. So that's going to give us negative 18 plus 24 minus 6 is going to be 18. I minus 8. We have two constants. You can easily combine them. 18i minus 26. Ooh, that's going to be your answer. Now for number 8, it's a little more complicated. You have more terms. But again, you treat them as x. So you have 5i cubed plus 2i squared minus I plus 5 times I squared plus 4i. So you want to divide this into each term. You want, well, this is small, so you're going to do that. Which is going to give you 5i to the 5? Yeah. Plus 2i to 4 minus I cubed plus 5i squared. Then you're going to add, multiply 4i in. You get 20 4 plus 8 third minus 4i squared plus 20i. Okay, so it looks very complicated. But it's actually not, because I to the 5th, you know, I to the 4th is 1. So if you multiply I to 1, that would just be I. So that's 5i. You know, I to the 4th is 1. So you get 2. And I to the 3rd is negative I. So negative of a negative I is positive. I squared is a negative 1, negative 5, and the 4th is 1, plus 20. I to the 3rd is negative I, it's going to be negative 8i. I squared is a negative 1, so you have plus 4 minus negative, right, and then you have plus 29, which you can't simplify. And now you combine like terms. You have 5i plus I minus 8i plus 29. So that would be 3 plus 1, 2, 18i. And for the constant, you have 2 minus 5 plus 20, that's 23, no, 17, plus 4 is 21. So, that is your final answer.
So, dividing, let's have an example of that, because it's one of the harder topics for complex numbers. So, for example, let's have the equation negative 3i plus 6 over I plus 4. So what we'll want to do with that is first multiply by the conjugate of the denominator. Since the denominator is I plus 4, the conjugate would be I minus 4. You multiply the equation by 1, so you have I minus 4 over I minus 4. Then what you should do is FOIL it out. FOIL the numerator and denominator. So, multiplying this, you would get negative 3i squared plus 12i plus 6i minus 24. Then with the denominator, should go I squared minus 4i plus 4i minus 16. So in the denominator, we have plus 4i minus 4i, which would be 0. I squared, which we know is negative 1. So, as right now, we have negative 1 minus 16. Then in the numerator, we have negative 3 times I squared, which is negative 1. That would just be 3. 12i plus 6i is 18i, and minus 24. Some simplification would give this to be 18i minus 21 over negative 17, which would be the answer, dividing negative 3i plus 6 over I plus 4. So here's a very hard example of dividing by complex numbers. We'll have 2i minus 3 over 4i plus 5, and have that entire thing over 2i plus 4. This is going to be tricky. However, if we start with the numerator, it won't be as bad. So let's start with dividing the numerator. Give one easier fraction to work with. So as we would normally, we would multiply by 1, the 1 being using the conjugate of the denominator. So we have 4i minus 5 over 4i minus 5. Foiling the numerator, we have 8i squared minus 10i minus 12i plus 15 over, we have 16i squared minus 20i plus 20i minus 25, and that's all over 2i plus 4. So now, as we would normally, we should simplify what we can with the I at the end. I squared is negative 1, so 8 times negative 1 would be negative 8. Negative 10i minus 12i would be negative 22i plus 15. Same thing with the denominator. I squared is negative 1. Negative 1 times 16 is negative 16. 20i minus 20i would be 0, which is very helpful here. And that minus 25 would be negative 25. Simplifying this here, give us 7 minus 22i over negative 41. So, now that we've got this, we put it back in the regular equation now. So this is still all over 2i plus 4. What we'll want to do here, so I rewrite this, is do the same thing as before. Multiply by the conjugate of the denominator. The denominator this time being 2i plus 4. So the conjugate would be 2i minus 4. 2i minus 4. So now we should multiply. Start with the denominator. 4i squared minus 8i plus 8i minus 16. And in the numerator, we could say it's all over negative 41. We would have 2i times 7 would be 14i. 7 times negative 4 would be minus 28. Negative 22i times 2i would be negative 44i. And then negative 22i times negative 4 would be plus 88i. Very nice numbers here. Yeah. So what we want to do here is simplify as we normally would do. 44i squared is negative 1. Negative 44 times negative 1 would be 44. 88i plus 14i would give me 102i. Then minus 28 from before, and that's over negative 41. And then with the denominator of the equation, I squared is negative 1. Negative 4, we get from negative 1 times 4 is negative 4. 8i minus negative 8. 8i minus 8i would be 0. And then you have minus 16 from before. A little simplification, you would have 102i plus 16 over negative 41 over minus 20. To simplify it a bit more, multiply by second below minus 20, 102i plus 16, over my 41, times negative 1 over 20. So what we want to do, multiply it quickly. Negative 102i plus 16 over negative 820. Get rid of the negatives, so final answer would be 102i plus 16 over 820. Very nice numbers here, but that's how you do it.
So that we went through was the concept of regular number and how to use them. That's number 1, and stuff. So yeah, hope you understand.
And learn your complex numbers.
And your magic.
Yes, magic.